All right, so again, if you can do this review, you can handle your quiz, which is Monday. So let's look at the first one. Rectangular field is to be enclosed on 4 sides with a fence. Fencing costs $4 a foot for 2 of the opposite sides, and $8 a foot for the other opposite sides. Find the dimensions of the field of area. They tell you the area right here, so I know 780, bless you. I'm going to call this side X and this side Y. So equals X times Y. That's how we find area, right? That would be the cheapest to enclose. So are we trying to minimize the area or something else? The perimeter, right? We want to minimize the cost of this fence is what we want to do, but we need the area to be 780. So perimeter, or rather we want the cost to be minimized, the cost of the perimeter. So we're going to say cost of perimeter. Well, we have 2 sides that are X, and those are $8 a foot. Plus, we have 2 sides that are Y in length, and those are $4 a foot. Does everyone see where my equation came from? $8 per foot here, and we have 2 times X. $4 per foot here, and we have 2 times Y. So are we supposed to find the derivative of the equation on the right or the left? On the right, because that's what we're going to minimize. So if this is the one we're going to minimize and derive, then what do I do with this guy? Isolate one of the variables. It doesn't matter which one. If I call this 780 over X equals Y, then everywhere I see a Y, I'm going to put 780 over X. I'm going to go ahead and put 16x on that, sorry. Plus 8 times, not y, but 780 over x. And 8 times 780 is 6240. And that's our cost of the perimeter. And that's what we're trying to minimize, so we take the derivative. And we get 16 plus, now remember, this is like 6240 times x to the negative 1. So I really have a minus or negative 6240 over x squared. Because this x to the negative 1 becomes x to the negative 2. So we see what happened?
No.
So this right here in my head, I'm thinking that's like 6240 times x to the negative 1. And then whenever you work out the derivative, this is what it looks like. Now what do we do? Set equal to 0. So I wind up with negative 16 equals negative 6240 over x squared. I've run out of space, sorry. Pointed it back this way. Multiply both sides by x squared. Divide both sides by negative 16. We get 390. Square root. We only care about the positive because distance or length has to be a positive. And that's 19.75. Oops. And that's in feet. And the question says to find the dimensions. So they want length and width. So I have 19.75 for x. What's the other one? How do I get it? Plug it back in right here. 780 divided by 19.75, and you get 39.5. Bless you. Feet. Any questions on number 1? No, because, I mean, you know that the answer you get, there's only one critical number. It has to happen with the critical number. Yeah, it's a good question. I hope you don't have questions on number 1. I can't tell you what's on the quiz, but I can tell you need to be able to do this problem. Number 2. A company is constructing an open-top, square base. That's where some of our problem comes from. Don't lose that word square because that happens on your assignment. Rectangular metal tank that will have a volume of 31 feet cubed. So, tank. It's got a square base. So I'm going to call that X and that X. And the volume, here's height, which is 31. Volume equals length times width times height. So that's why I get X squared H. Questions so far? What dimensions, so it wants to know all 3 values, yield the minimum surface area? So I need an equation for the surface area. Well, it's open top, so I only have to worry about the bottom, not the top. The bottom is going to be X squared plus the front face is X times H, which means the back is also X times H. The left side is X times H, which means the right hand is also X times H. So there's 4 of those. Any questions before I got that? Okay, yes?
Well, problems like that, will it always just be 4x each?
If there's a square base, then yes. Good question. Because it makes a cube. Well, not. I guess it doesn't make a cube. I guess this could be really tall. But yeah, I see what you're saying. The sides will all be the same. Which one of these are we going to derive? The one on the left or the one on the right? The one on the right, because it says minimum surface area. So before I take the derivative here, I need to have all one variable. So I'm going to solve for H over here. This is just like one we did on your assignment earlier. So everywhere I see an H, I'm going to put in 31 divided by X squared. And I simplify it. And I get 124 over X. Is that right? Whoops, I don't know why I put equals. Sorry. Is that 124?
Yeah.
Over X. And now we take the derivative. So we have 2x minus 124 over x squared. So we know where that came from. Same reason the last one kind of turned out like that. In my head, I'm thinking that that is 124 times x to the negative 1. Power rule makes it look like that. Now what? So it equal to 0. So then I wind up with negative 124 over x squared equals negative 2x. Multiply both sides by x squared. Divide both sides by negative 2. Cube root. Bless you. It says to round to the nearest tenth. So what happens when you round that number to the nearest tenth? 4.0. The 0.0 tells the reader that you round to the nearest tenth. If you just put 4, the reader doesn't know that you rounded. So that's our x values. So it's going to be 4.0 feet by 4.0 feet by h. To get h, we plug it into this equation right here, and it's 31 divided by 16. 1.9 feet. Questions on 2? You need to. Sorry, go ahead.
When you have the surface area, like x squared plus 4x, how did you explain that?
Sure. So the x squared, Carson, came from the area of just the bottom. And it says it's open top, so I don't have to worry about the top of the prism. And then the left side, if you'll see, that's x times h, right? Which means this right side is also x times h. So there's 2 of those. And then the front is x times h, and so is the back x times h. So there's 4 x times h's.
Okay.
All right, next one. Of all numbers whose sum is 460, the two that have the maximum product is what we want. So we're adding two numbers together to get 460, and the product we want the maximum of, and they even give you the equations. They're super nice on this. They give you both equations. Are you going to derive the one on the left or the one on the right? The one on the right, because it says maximum product. Good. So we're going to use the one on the left so that we only have one variable going on over here. So we have y equals 460 minus x. So we have x times, instead of y, we have 460 minus x. I'm going to distribute. You do not have to, because I want to take the derivative, and this makes it a little bit faster. Set it equal to 0. We should get 230. If I take 230 and I plug it back in right there, my y is also 230. So the two numbers are 230 and 230. Questions on that one? So if those three problems are on your quiz, can you do the quiz? Terrific. Let's move on. Find the dimensions that produce the maximum floor area for a one-story house that is rectangular in shape and has a perimeter of 127. So x, y, x, y. They want a maximum floor area. Well, we know the area is going to be x times y. They also talk about perimeter, which we know is 2x plus 2y, and they tell us that it's 127. Are we going to derive the equation on the left or the equation on the right? On the left, because it says maximum floor area, which means we need to use this one to make this one all the same variable. So I'm going to subtract 2x from both sides and divide both sides by 2. And actually, this will be even easier if I make these two different terms. Do you guys see what just happened? I took 127 over 2 and negative 2x over 2 to get 127 over 2 minus x. And I'm going to take that and I'm going to plug it into this equation. So that I have area equals x times 127 halves minus x. I'm going to distribute my x to make the derivative a little bit easier to find. Bless you. And we find our derivative because we're looking for the maximum floor area. Once you find your derivative, what do? Equal to 0. Don't mess up the last step because you forget how to do fractions. You have a fraction divided by 2 over 1. So you're multiplying by 1 over 4, or 1 over 2, correct? So we wind up with 127 over 4, which is, I don't know, what is that? What was it? I'm sorry. 31.7. So really 31.8. We can round to the nearest tenth. And that's our x value. You can take that value and plug it back in up here, over here, sorry, to find your y value, which I think is the same.
It is.
Also 31.8. Which, again, these rectangle problems, I think I told you guys this. When you're maximizing area of a rectangle, it is a square. So the dimensions are going to be 31.8 feet by 31.8 feet. Make sure you know how to do that one. Last one. If the price charged for a candy bar is p of x cents, then x number of 1,000 candy bars will be sold in a certain city, where this is the price per candy bar. How many candy bars must be sold to maximize revenue? I need revenue. And revenue is the price of the item times however many you sell, right? So I have X number of thousand times P of X, which is 100 minus X over 36. I'm going to go ahead and distribute to make it easier to differentiate. Because we're looking for maximum revenue, we go ahead and we derive the revenue equation. We get 100 minus, if I multiply by 2, that's going to produce 2 over 36, which is 1 over 18 X. Does everybody see what happened? Yes, sir. So if we have this right here, I'm thinking that also means 136 times x squared. It's the same thing. So you take the 2 times 136, then that's 236 times, now that's an x, and then that reduces to 118. Does that make sense? Okay. Good question. So now we have our derivative, and we set it equal to 0 to find our critical number, which is where the maximum number takes place. And 100 times 18 is 1,800. Is it 1,800 candy bars or a different number? Times 1,000, he's right. It says X thousand. So how are you going to do 1,800,000? Or is it just 1,800? What, Brian? Or you could put 1,000. Yeah. No, though, we got 1.8 because we did it differently last hour. We got 1.8 thousand, so that would be at 1,800. I think that would be 1,000 though. So that is X. Candy bars. Let me double check that really fast before I say this wrong. I don't know if I have the answers here somewhere. I don't.
So you saying we use 1,800?
No.
That's
So many problems. But the answer key is, but that's what X comes out to, so it's got to be 1,800,000. I'm thinking.
yeah, it is.
Which is the same as 1,800,000, isn't it? You add, if you add 3 zeros, it's the same thing as 1.8 million. Yes? It is weird. It is weird to say that. 1.8 million would make more sense, but they say X thousand. So I just left it like that. It doesn't matter. Alrighty, so there is your review. Study, study.